Welcome back, scholars. Today we're going to take a look at solving rational equations. That is, equations where our variables are found within the numerator and/or the denominator of a rational expression. Let's get started. To begin, we're going to bring some ideas that we've been developing with rational functions and expressions. Let's start by analyzing the rational equation we are given and noting a few things. First, I see that there's two rational expressions, one on the left-hand side and another on the right-hand side of the equation. Most importantly, there's an equal sign between the two expressions indicating that we can solve for the value or values of x that make this statement true. Next, I want to think about the implied domain of this equation. In other words, what value or values of x are excluded from this statement if we're to assume that x is a real number and that the value of either rational expression on the left or right-hand sides are real numbers as well. Well, we cannot divide by 0. So any value of x that would create a 0 in the denominator would need to be excluded. So I'll go ahead and make a note here that x cannot equal 3. Alright, now we'll get to the actual solving. I see that we already have a common denominator between the expressions on the left and right-hand sides. So that means that the numerators are equal to one another as well. To simplify, I'll simply eliminate the denominator from both sides. This would algebraically be the same as multiplying both sides of the equation by x minus 3. From here, I'm just solving a simple one-step equation. I'll subtract 2x from both sides, and I have x equals 3. However, let's look back and note the excluded value. We said that x cannot equal 3, so we'll classify this answer as extraneous and state that there are no real solutions to this equation. Let's look at a second example. Note this time we do not initially have a common denominator across all three terms, so we'll need to address that. In the meantime though, let's see what values of x we must exclude. That will be just x equals 0 for this x in the denominator here. Now, let's think about how we can quickly and easily apply a common denominator to all three terms and also eliminate any fractions. Let me show you what I mean. We can think of the purple denominator as a 1 and the blue denominator as an x. To make a common denominator, I would need to multiply both the purple terms by x over x. On the other hand, if I multiply every term in the equation by just x, I'll eliminate the blue denominator entirely. Then we don't have to worry about combining any fractions. So let's try that approach. I'm going to multiply every term in the equation by x. Now, be careful here. X times x gives x squared. X times 8 over x, well, that common factor of x divided by x will reduce to just 1, so x times 8 over x will be just 8. And x times 6 will be 6x. Now we have a quadratic equation. We'll bring all terms together, setting the right-hand side equal to 0, and we'll solve by factoring. I have x squared minus 6x plus 8 equals 0. In factored form, I have x minus 4 times x minus 2 equals 0. That means x equals 4 and x equals 2. Now, let's look back at our excluded values for x. That's just x equals 0, or x not equal to 0. So this time we have two solutions, x equals 4 and x equals 2. Let's check out number 3. This time we have 3 rational or fractional terms. 2 of the terms share the same denominator. I've highlighted that one blue. The middle term has a different denominator, and I've highlighted that one purple. As we did in the second example, I'd like to eliminate the fractions entirely. We're going to do that by multiplying every term in the equation by what would be the common denominator of these 3 fractions. Here's how that's going to look. I'm going to multiply every term by 3 times x plus 2. And let's go ahead and leave that in factored form. Now, let's focus on the first term. I've got 3 times x plus 2 times negative 2x over x plus 2. I see that the common factor, the blue common factor, x plus 2, is going to reduce down to 1. So this leaves just 3 times negative 2x, or negative 6x. Next, we have 3 times x plus 2 times x over 3. Again, the common factor of 3 will reduce down to 1. This leaves just x plus 2 times x, or x squared plus 2x. Last, we have 3 times x plus 2 times 4 over x plus 2. Once again, that blue common factor of x plus 2 reduces down to 1. This leaves just 3 times 4, which is 12. Once again, I have a quadratic equation, so we'll bring all our terms together, set the right-hand side equal to 0, and solve by factoring. I have x squared minus 4x minus 12 equals 0. In factored form, I have x minus 6 times x plus 2 equals 0. This means that x equals 6 and x equals negative 2. Let's look back at our original equation. We see that x cannot be equal to -2, so we'll exclude that solution or classify it as extraneous. That means that we have one solution to this equation, which is x equals 6. Let's check out a fourth example. Taking a quick look at the three terms, I see that we have an x squared minus 9. We see that binomial all the time, and of course we know that it factors into x minus 3 times x plus 3, which happens to be a combination of the two denominators of the other two terms. We'll approach this the same way that we did the previous two examples. To eliminate the fractions, we'll multiply by what would be the common denominator across all three fractions, x minus 3 times x plus 3. Alright, we'll go one term at a time. For the first term, the blue factor, x minus 3, will reduce to 1, so that leaves just x plus 3 times x, or x squared plus 3x. For the second term, the purple factor, x plus 3, will reduce to 1, so that leaves x minus 3 times 2x, or 2x squared minus 6x. For the right-hand side, we have both factors in the denominator, so this will reduce to just 18. We'll solve this quadratic by factoring. Note that there's a GCF of 3 across all three terms. We'll have x equals 3 and x equals 2. Let's compare that to our original equation where x cannot be equal to positive or negative 3. So we'll have just one solution here, x equals -2. We have one final example, and it uses all the same techniques that we've seen in the previous four examples. Go ahead and factor the denominator of the fraction on the right-hand side. Then eliminate all fractions by multiplying by the common denominator of all three fractions. Pause the video for a few minutes while you work through this one solo. Okay, let's see how you did. After eliminating fractions, we have a quadratic result. Its factored form can be used to find the two potential solutions of x, which are -1/2 and +3. Looking back to the original equation, I can see that x cannot be equal to 2 or 3, so that means that this equation has just one solution, which is x equals -1/2.